Alright, so this is your volumes of solids test review. Alright, so number one says, find the volume of the solid of revolution generated when the region under the function f of x equals 5x plus 1 is rotated around the x-axis from x equals 2 to x equals 6. So as you know, when you rotate this, you're going to get circles. So we're going to have to use the formula for a circle when we integrate this. Alright, we know we're integrating from 2 to 6 because it told us. And we know we have to do pi times radius squared. Well, we know our radius is 5x plus 1. So there we go. There's the setup. So now you know you can pull the pi out. 2 to 6. Go ahead and square this out. 25x squared plus 10x plus 1 dx. Now take the antiderivative, which is going to be pi times the antiderivative of 25x squared is 25x cubed over 3 plus, this would be 10x squared over 2 or 5x squared plus x evaluated from 2 to 6. Alright, so pi, when you plug in the 6, you get 25 times 6 cubed divided by 3 plus 5 times 36 plus 6. Of course, you're going to subtract from that. 25 times 8 divided by 3 plus 2 squared is 4 times 5 is 20 plus 2. And of course, all that's going to be multiplied by pi. So your answer is going to come out to 5,692 pi divided by 3, or as a decimal, which I would take either answer, would be 5,960.65. Alright, so that's number one. Alright, here's question 2. It says, find the volume of the solid of revolution generated when the region defined by f of x equals 3 minus x squared and g of x equals x squared minus 1 is revolved around the line y equals 4. So we're not revolving this around the x-axis, we're revolving it around the line y equals negative 4. So the first thing we need to do, we need to figure out where they're going to cross. Alright, so to do that, you simply set the two functions equal to each other, and this will let us know where we're integrating to and from. So plus x squared, oops, minus 3, minus 3. So 0 equals 2x squared minus 4. Add 4. 4 equals 2x squared. Divide 2, divide 2. 2 equals x squared. Take the square root. So x equals plus or minus the square root of 2. So this is our to and our from. Okay? So let me write that down. Plus minus the square root of 2. Okay. Now, let's figure out which function's on top and which function's on bottom. Well, it's really easy. Since this is negative x squared, we know it's concave down. Since this is positive, we know it's concave up. So we know that this has to be our function on top, and this has to be our function on bottom. Alright? So now we're just going to subtract the two from each other. But before we do that, let's go ahead, because we know that we have our functions, but we're revolving around the line y equals negative 4. So to get back up to the axis, we're going to need to add 4. Alright, so 3 minus x squared plus 4. This is going to be our new f of x. So that equals 7 minus x squared. And then let's do it for g of x as well. X squared minus 1 plus 4. So it's x squared plus 3. Alright, so these are our two new functions that we're going to use. So now what we need to do is we need to subtract the bottom from the top. Alright, so our top is 7 minus x squared minus x squared plus 3. So we have 7 minus x squared minus 3. So we have negative 2x squared plus 4. Alright, so that's the function we're going to be integrating, is negative 2x squared plus 4. pi out here, negative square root of 2, positive square root of 2, negative 2x squared plus 4 squared dx. Alright, so now square it out first. So you get pi, negative square root of 2, square root of 2, you get 4x to the 4th plus 16x squared, minus 16x squared plus 16 dx. Take your antiderivative, and you're going to end up with 4x to the 5th over 5 minus 16x cubed over 3 plus 16x evaluated from negative square root of 2 to positive square root of 2. Alright, now you just simply plug in the square roots. So your answer comes out to be 256 times the square root of 2 over 15, which equals as a decimal 75.825. I would take either one. Oh, don't forget the pi. I would take either one of those answers as correct. Alright? I would take either one of those answers as correct. Alright. Now let's go to number 3. Here's number 3, partially sketched out already. Now, we're revolving this around the y-axis. We have y equals the square root of 4x, and it's also bound by x equals 7 and x equals 0. Alright? So, we're revolving around the y, so the first thing we need to do is solve this for y. So we're going to square both sides. So y squared equals 4x, divide 4, divide 4. So x equals y squared over 4. Alright? So now, to find our upper limit of integration, all you have to do is plug in 7 to this equation. When you plug in 7, you get 2 to the square root of 7, or as a decimal, you get 5.3, but I'm going to use 2 square root of 7. Alright? So now this is what we're integrating from 0 to 2 times the square root of 7, because we're revolving around the y-axis. Alright? So 0 to 2 square root of 7 pi times y squared over 4 squared dy. Go ahead and square that out. So you get pi 0 to square root of 7 of y to the 4th over 16 dy. Now take your antiderivative, and you get pi from 0 to 2 square root of 7. Take an antiderivative. Where did I do that? So you're going to get y to the 5th over, now since this is over 16, and we're going to put this, we're going to multiply by 1/5, the 16 times 5 is 80. And we're evaluating from 0 to 2 times the square root of 7. Alright, of course when you plug in the 0, you're not going to get anything. So you plug in the square root of 7, and you should get 98 pi times the square root of 7 over 5, or your decimal would be 162.913. Alright, so there's number 3. We're revolving around the y-axis, and we're going from 0 to 2 square root of 7. So you solve your function for for x. X equals y squared over 4. You plug that in and square it. And then from there you just find your antiderivative and substitute in. Alright, number 4. Number 4 says, find the volume of the solid with a base formed by the function f of x equals cosine x from x equals 0 to x equals pi over 2. Alright? With square cross sections that are perpendicular to the x-axis. Alright, so if we were to draw this, we know that we start at 1 and we come down, and when we hit the x-axis here, this is pi over 2. Alright, this is 0 and that's pi over 2. Alright, so we know our limits of integration, because this is what we're integrating. We know our limits of integration are 0 to pi over 2. But now, since our cross sections are squares, we know the formula for a square is side squared, and of course, cosine of x, that gives you your side. So we're going to have the cosine of x squared dx, and that's what we're going to integrate. All right. So when you take your derivative of cosine squared, you get 1/2 times x plus sine x times cosine x, and of course evaluated from 0 to pi over 2. Now when you evaluate this, something weird kind of happens. All right, when you plug in pi over 2 for sine x and cosine x, for the sine x it equals 1, but for the cosine of x it equals 0. So really, when you sub in the pi over 2, all right, you're really just left with the pi over 2, because this is 1 times 0. Plus, plug in the 0, you get 0, plus the sine of 0 is 0, and the cosine of 0 is 1. Well, of course, this just cancels out to 0. This cancels out. So really, your answer is just 1/2 times pi over 2, which is pi over 4. So this whole long, complicated problem, the answer is pi over 4. That's it. All right. I would remember this antiderivative too. It might help you on tomorrow's test. I'd make sure I remember that because of tomorrow's test. Did I say remember that for the test tomorrow? All right, number 5. Number 5, when you first read it, it sounds like you're actually integrating a different area than you're actually integrating. Here's what I mean by that. It says the volume of a solid with a base formed by f of x equals 4 minus x, and g of x equals x minus negative 2, which is x plus 2, and x equals 0 with equilateral triangular cross sections. All right. So if you were to graph this, all right, if you were to graph this, 4 minus x, that's negative x plus 4. So 1, 2, 3, 4. Down 1 over 1. 1, 2, 3, 4. So here's our first line. And then this one is x plus 2, so it's a positive slope. Moved up 2, so 1, 2, 2. And the line x equals 0, which is the y-axis. Alright, which is the y-axis. Now, most people would think it's this section here that you're taking the derivative of. I mean the area of. But it's not. Because this is also constrained by y equals 0. Alright? What you're actually taking the area of is this little triangle there. Alright? It makes the problem a lot easier when you realize that too. Okay? So now, we need to find out where we need to integrate from. Set these equal to each other. Solve for x. So when you set them equal to each other, you get 4 minus x equals x plus 2 plus x minus 2 minus 2. So 4 minus 2 is 2 equals x plus x is 2x. Divide 2, x equals 1. So we're integrating from 0 to 1. Alright? Because we know we're constrained by x equals 0, so we know that's where we're starting, and then we're ending where they cross, which is at x equals 1. Alright, so now we need to figure out the function on top, subtract the function on bottom from that. Well, we know that the 4 minus x is the function on top, so 4 minus x plus 2. So 4 minus x minus 2. So this is negative 2x, and then 4 minus 2 is positive 2. So that's what we're taking the antiderivative of. So from 0 to 1 of, now, our formula for the equilateral triangles is the square root of 3 over 4 times the side squared. Well, that square root of 3 over 4 you can pull out. And then it's just times side squared. So, negative 2x plus 2 squared dx. Alright, so now you just got to take the antiderivative. Well, square it first, I'm sorry. So square root of 3 over 4, 0 to 1. Square this, you get, what is that, 4x squared minus 8x plus 4. Yep. Dx. Alright. So, antiderivative, we know it's going to be multiplied by 3, square root of 3 over 4. This is going to be 4x cubed over 3 minus 8x squared over 2, or just 4x squared, and then plus 4x, evaluated from 0 to 1. Of course, you know when you plug the 0 in there, you get nothing. So this is simply going to be, this here, when you plug in a 1, it's going to give you 4/3, and this is minus 4, and then plus 4, so that cancels. So this is simply going to be the square root of 3 over 4 times 4 over 3. The 4's cancel, leaving you with the square root of 3 over 3. And that is your final answer. Alright, that is the area of this with cross sections perpendicular to the x-axis being equilateral triangles. Alright? So, this has been your Chapter 6 Volumes of Solids test review. You can watch this as many times as you need to. Make sure you come ready to take the test. See you tomorrow.